everybody, welcome back to Around the Emirates podcast with Sara Mousa, where I speak to guests from across the UAE about topics you want to hear about. Today, I'm joined by the awesome Dr. Sherif Yehia, who is a professor of civil engineering at AUS and a lead inventor at the university with a very cool invention to share with us. Hi, Dr. Sherif.
Hi, Sarah. Thanks for inviting me. Thank you very much. Um, so we're here to answer all your questions and help explain everything about the pattern.
Awesome. So you of course, with your team have come up with a really cool invention, which is a concrete structural system that is now US patented. I am so curious to hear all about your journey in creating this invention.
Sure. First of all, before I start talking, I have to give credit to all my research team. So when I'm here, I'm talking and referring to the research or all the activities. Yes, I'm the lead inventor, and I did the work with my students and my co-researcher, but I cannot take the credit from everyone. So I have to make this clear from the beginning, so I can explain exactly what happened through the journey of the development. So the first thing, as Sarah mentioned, that the patent mentioned the concrete structure system. This is a concrete structure system. To be patented, you should offer something unique and new. So, and it goes through a process. Later on, we can explain the process for getting the patent approved. But now let's focus on the patent itself and what the content of it. The patent offer a structure system which can offer two-in-one to support the structure loads, everything we planned for it as civil engineers, gravity load, dead load, wind load, and all other loads we should consider. Plus, which is the really important thing, which is made it unique, it offered a solution for electromagnetic shielding, which is protection against magnetic attacks, waves attacks, which is targeting the computers, sensitive data centers, everything related to working with computer and smart cities. So the structure itself, the concrete, which is we used and we patented through the structure system, offer this kind of a unique characteristics, which under so many circumstances, structures get exposed to this kind of attacks with the electromagnetic shielding. And we know that all of us depend on computers, all the power plants or data centers. They utilize the computer and cannot just go anywhere. And all the smart cities planned, everything related to that. So these kind of things could be happen either natural waves coming from high above, which is we cannot control, and also some attention attacks, which is could be generated by an unfortunate event targeting this kind of sensitive information. Yeah. So the idea came that if we can reduce this kind of a structure system, combine between the two things, that the structure provide all the requirements for the structure system, at the same time provide this kind of a protection, will provide a really good solution for us. One might ask, oh, we don't have anything right now in the industry can help this or provide this solution. We're saying, yes, we cannot just deny that. We have a lot of solutions. However, these solutions, most of the time, they are add-on. Add-on means what? That means that you build a structure, and after that, you start finding a specific place or area you're trying to provide the protection, and you contain the equipment within this kind of area. Usually they are add-ons, they're expensive, and also at the same time, they limit the space of use. So now we're saying, by the new system, we provide the whole structure. We can provide you the protection. At the same time, it help you, no limit for the space, help you locate your equipment and everything with that. So this is where the beauty, and this is the reason for the patent that was awarded from the United States, because it provides a complete solution for this kind of a problem.
That is very, very cool. I appreciate the fact that you have gone into so much detail to explain to me the process, because I literally have no context on civil engineering. But it's very, very cool that you and your team have been able to do that. And what kind of challenges came along in the process?
The challenge usually it comes from so many different directions. First of all, I've been working in this material development, especially the conductive concrete material, um, about 25, 30 years or so. And I went through several scenarios for production and different applications and so forth. When I moved to United Arab Emirates and where I started working with my partner, research partner, Dr. Nasser Qadoumi, is from the electrical engineering department. We started working in 2009 through the funds from the university. To just take it one step at a time to see how we can do whatever I did back there in the United States and just trying to use our local material here in United Arab Emirates and see exactly how we can resolve issues related to the availability of material and so forth. And during the years, we went through ups and downs with just the evaluations, and we're trying to be sure that this material gonna work at under any circumstances, because the idea that is not just only doing research, doing an applied research, which is your target is at the end of the day, this product will be used with the government and all the facilities and community outside. So beside the structure support and the protection against electromagnetic shielding, you have to think about durability, long-term of the use of the structure, and everything related to maintenance and how you can maintain this kind of structure and so forth. So within the first 10 years, we went through so many different scenarios in the lab setting, which is until 2019, where I just try everything. We try our material. We went through using the regular construction industry products, aggregate and so forth. What if we need to reduce the dead load of the structure? Let's use a lightweight. So we use different lightweights, and we start going through all the scenarios. And every time you work, you need to be sure that it is not just happen in the lab and you're happy with the one event. You have to keep trying until repeat it and repeat it again and repeat it again. And probably when my students listen to this podcast, they will know that I don't take the first answer. I say, okay, yeah, let's go back again. We have to try it again. We have to try it again until we just be sure that everything is okay. As you imagine, during the course of the 10 years, we had so many bright students working with us at the master level and undergraduate level, and they were really a great group, with their feedback, working with me in the lab and long time and keep repeating and all these kind of things. So this is a kind of one of the things you have to encounter during the process, that you have to have confidence with the product you're trying to promote. And this kind of promotion will not going to happen unless you're really doing things by hand. You go to the lab and you know exactly the problems you're going to face. The next is to test you have to what to do to make it workable. You put yourself in the shoes of the people gonna place it and finish it. What other problems you're gonna face? We have to enhance it and so forth. And after that, how we can put it in several molds, because our product, we can put it in the concrete itself. We can produce it in any shape you want, domes, curves, whatever. So this is where you start trying until we reach in 2019. Dr. Nasser and you decided that I think this is a time for us to go with an implementation project. And this is the key, actually. And this is where the big things for us, because now we have the product. We know exactly what to do with the material. We have the scientific evidence to prove that it's working fine. And also at the same time, we need to move forward with the implementation project with a major thing for us to do, because at this time we need to transfer our knowledge to the industry. And from there, we start working with the group from industry and construction industry group, contractors, ready-mix producer, precast producer units, and so forth, to see exactly how we can make things happen. Because you have to have some flexibility that what you're doing in the lab, it needs some adjustment when you go to the workplace,
right?
To just produce a big quantity. Yeah. So you're producing 2 or 3 cubic feet at a time with the students, and you can adjust it with your mixer and here and there. But when you go with producing 50 cubic meter or something of concrete, what's going to happen with this? With all things related to the science for the cement and hydration, transportation from the ready mix producer to the casting place, all these kind of things, you have to account for it while you go. So the implementation project came, we applied for a grant through the regular process at AOS, and we were awarded the grant. The preparation for the grant actually took a lot of time. It took about a year or so, because before we apply, we had to get in contact with so many people from the industry to seek their support. Some people, they get so excited with it, and some people, as usual, looks good, but it work or not. So they are not really enthusiastic with it, so excited with it as we are. Definitely trying to promote your things, and you have all your passion and everything to produce and present it to people. But you shouldn't expect that everyone will fall in love with it in the same way you work on it. So we had to prepare so many meetings with the industry people, and we were so lucky. We got so really a good people working with us, and shows the support from A to Z. The first thing, as I mentioned, that we have, I give credit to my students and my research partner, but also we have to give credit to the people supported us. Mr. Hussein Hamoudi from Sharjah Research Innovation Research Park. He was phenomenal. Actually, showed the support when we had a meeting with him. Mr. Hussein mentioned that you have my support. We need a piece of land. He said, done. We need this done. So he was showed the support all the way. Yeah, it was really encouraging us that he believed on us. And I think Mr. Hussein, one of the people that I really admire, that he understands the market, and he knows exactly what to do. And this was really one key person. He did help us through the process. And also from the construction industry, we had to work with the ready mix producer. Also, we had a meeting with the head of the company there, and an engineer. I cannot forget his name, Mr. Adil William. When I talked to him, he said, "Let's do it. Not a problem. Let's find a way to do it." So it is really great way. Because as I mentioned, these kinds of things, if you cannot find the people support us, use through it to transfer, I said, okay, this is what I do in the lab. Let's see exactly what we can do to transfer it to the really ready mix producer plants. And he was really 2 or 3 days, every day I go there with his group and try to do it, try once, try twice, work fine, feel confident, let's go move forward to cast. And also the one also from the beginning of the project, from Alec construction company, Mr. John. This man, I can keep talking about.
I love the support system you have, honestly.
yeah, because this man is a quality control manager at Alec, and he gave us so many advices. He give us so many contacts because he believed on us. Actually, like similar, to Mr. Hussein and support we get from the Sharjah Research Park. Mr. John, he was really excellent person. I'm still, actually, I was talking with him up two days ago. He is really a good source of information and knowledge, because he deals with so many things related to the construction, and he gave us so many good tips. And he said yes, and he dealt with the company, all the regulations and everything, and we decided to do the panels back there at the plant, Alec plants in Jabal Ali. We had also a great group there, and they were really helpful. The idea is we tried to get the precast unit, because this is the structure system we're promoting. So the structure system, you have to go through a production phase and also transportation phase, using the regular trying to simulate exactly what's going to happen at the construction site. So we went there, and I still remember the day, which is the end of May 2003, something like that. We went Jabal Ali, temperature 45 degree, and and all the guys and workers doing an excellent job there. And we get all the units ready in one day, and we had to cure it definitely for the structures for 28 days and so. And we started working and erecting at the end of the after 6 months or so, until we arranged everything. Also, one of the good things that about the project and the implementation projects we try to do is to simulate the other benefit of this kind of a precast unit, because you can prepare everything off-site, everything, walls, slabs, foundation, and the only thing is you take it and move it to the site. Only time you need is to erect things together and get it done in short time. So, and he said, this is a really a good opportunity for us. Why we don't try this? And we tried everything. So we tried the foundation precast, all the units precast. And as I mentioned, Mr. John from ALEC, the design group from ALEC also, they are great guys. You know, we had so many meetings, and we'll sit down and talk about possibilities, what we need to do, how we can do it, how we can adjust, and all these kind of things. These guys were really, really a good contribution to the success of this kind of an implementation process. And we reached a time where we erected everything. We had another engineer, small company dedicated for working with precast, Mr. Passem from IBA Construction. He's really a great person as well. Also, we told him, this is the limited amount of money we have. We need to erect the units. He said, done, whatever. So he's really showed his contribution to the project and support for us. And we got everything, he got everything done in 3 days. He erected the whole structure, which is the one of the unique things which we try to emphasize as well, that prepare everything you want off-site. Don't keep in mind that the transportation, the don't hold the truck. That's it. You just moved it, erect, get the crane. 3 days, we get all the pieces together. After that, we finish it and we get all the other requirements for the implementation process. By the way, I'm talking about the prototype at the Sharjah Research Park right now. It's a live structure, which is, we tested after that. Dr. Nasser and his group tried everything to prove. And actually, we were sure that it's working fine because we did our work in the lab. But when we went there, he said, Sherif, it's super. It's more than what we expected, because we said, in the lab all the time, you say, okay, yeah, let's try again. Maybe there is something here and nothing there. But now we went through the whole production, and we have a structure connected together and everything. And when he did the work, we get results more than we expected. Yeah, so it was really a great job. So one, as I mentioned, that the either most of the people I mentioned, actually, ALEC didn't charge us anything. This was a kind contribution from their side. Nothing, zero.
Nice.
The company Biton, Mr. Adel Williams, they didn't charge us anything also as well for the mixing and preparation. I had the plant for the project occupied for about 5-6 hours beside whatever they did, and they didn't charge me a penny actually. So it was a great contribution, and it did show to us how the construction industry and people and the academia can work together to make things happen. And I think this was a great example. And Mr. Hussein all the time said, this is a great example for a project came from the university with all the, the means of success, and moving forward to transfer it to the industry and showing that, yes, we can do it. And so far it's working fine. During this kind of a process, definitely, this is by nature. We have to give a credit for people who contribute to us, and we cannot just ignore the support and contribution from the president of the university until everyone. Yeah, it just goes without saying, every single one from the university, they were just getting from their way to support us. The IP office, the technology transfer office, also everywhere I go, they come with me. We need to ensure that the non-disclosure agreement needs to be signed, explain the process, because during this kind of a
Yeah.
process, they advise that just let's protect the product right away. So, and this is what happened. As soon as we start getting things materialized and things start showing, we applied
Yeah.
went through the process and we applied for the patent, and it took time because these kind of things usually it goes through review. You send the comments and you rebattle and you come back again, explanation, and at the end it just was awarded August 12th this year.
Awesome. Thank you. Thank you so much, Dr. Sherif, for sharing that super detailed story and for taking me through every amazing milestone of your journey. I've really enjoyed speaking with you today and hearing all about this really, really cool invention. And I wish you the best of luck in your future inventions.
Thank you very much. Thank you very much, Sara. Thanks for helping to spread the knowledge about the efforts we do in our university and how we connect with the industry. I really appreciate that. Thank you.
Awesome. Have a great day. Thank you. Bye.